Presentation is about points of discontinuity in reciprocal functions. Points of discontinuity occur at any location on the graph where there is a break. That means anytime we have to lift up our pencil, move it to a different location, and continue graphing. Points of discontinuity occur at the restrictions because those are the x values that aren't allowed to be on our graph. There are two types of discontinuities: holes and asymptotes. Holes occur at the location of restriction that can be factored and canceled out from the fraction. Asymptotes occur at the location of restrictions that cannot be factored out of the denominator. So we have y equals x plus 1 over x squared minus 4x minus 5. Our goal is to identify where the locations of discontinuities are, and then we're going to graph this function. So the first step is to factor the denominator. Once we factor the denominator, we are going to identify the domain restrictions. So here the domain restrictions are x cannot equal -1 and x cannot equal 5 because those are the two locations that would make the denominator equal to 0. Our next task is to determine if the restriction is a hole or an asymptote. We're going to do that by seeing if anything cancels out. So we have x plus 1 in the numerator and the denominator. They cancel out. Therefore, that means the hole is at x equals -1 because it cancels out, and the asymptote is at x equals 5 because it stays in the function. So the simplified version of this function is y equals 1 over x minus 5. These two graphs are going to be almost identical. So the way we start off is with the simplified version of the function. We're going to graph y equals 1 over x minus 5. The only thing different between y equals 1 over x minus 5 and x plus 1 over x squared minus 4x minus 5 is there's a hole at x equals -1. To find the location of the hole, we plug in -1 into simplified equation. So we plug in -1 into 1 over x minus 5. So we get -1/6. So the way we finish our graph is there's going to be a hole at -1 comma -1/6. So we go over to x equals -1. We erase a piece and draw in a hole, because that value x equals -1 is not allowed to be in any part of our graph. The second problem we have y equals 2x plus 4 over x squared plus 9x plus 14. We're going to start in a very similar way. We're going to factor, cancel out, identify what kind of discontinuity we have at our two restrictions. The asymptote is at x equals -7 because x plus 7 does not cancel out. The hole is at x equals -2 because that factor canceled out. We start the graph with the simplified version, 2 over x plus 7. After we get that graph, we're going to identify the location of the holes. Plugging in -2 into the simplified equation, location of our hole is at -2, 0.4. So you're going to go over to the graph at -2. You're going to erase a little piece, draw in a hole. So that symbolizes that we do not want x equals -2 as part of our graph. 2x squared plus 3x over 2x cubed minus 5x squared minus 12x. We're going to start very similar fashion. Factor and cancel out. This graph is going to have two holes at two separate locations because two of the factors canceled out. So we have a hole at x equals 2 and x equals -1.5. And the asymptote is going to be at x equals 4 because that was the only factor that didn't cancel out of the function. So we start with the graph y equals 1 over x minus 4. Identify the location of the holes. Graph 1 over x minus 4, except for the two holes at x equals 0 and at x equals negative 1.5. The other type of discontinuity we have are horizontal asymptotes. We've talked about horizontal asymptotes when we have the function in the form of y equals a over x minus h plus k. In this first example, when the powers are the same, we are going to manipulate the fraction we have into a similar form where we can identify the k value. So in order to do that, we are going to use our long division polynomial skills. So that means we are going to set up a box, put our divider on the outside, so 2x minus 1. 4x goes in the top left corner. We ask ourselves, how many times does 2x go into 4x? And the answer is 2. To find the bottom left, we multiply 2 times negative 1. We have 4x minus 2, but I want 4x plus 3 like in my original equation. So in order to do that, I need to add in 5. So 5 is my remainder. What this helps us do is it helps us rewrite our original fraction into the standard form for reciprocal functions. What we've just done is identify that the k value is 2 and the a value is 5. The a value is 5 because it's the remainder. So that's the part that remains on top of our denominator 2x minus 1. Now that we have it in this form, we can identify our horizontal asymptote is at the k value y equals 2. There is a shortcut whenever the powers are the same, and that shortcut is to divide the coefficients of the terms with the highest exponent that will give you the asymptote. So we could have identified the two coefficients next to the x terms, so that's 4 and 2, divided those two numbers, and we would have gotten 2 as our final answer for our asymptote. The final two cases are when the power is greater in the denominator, so an example would be y equals x plus 3 over x squared. Whenever that happens, the asymptote is going to be at 0. You're going to learn the proofs behind these two cases next year when you take pre-cal. And then the final case where the numerator power is greater, so x cubed over x minus 5. It doesn't matter how much greater it is. If the power on the top is greater, we are going to have no horizontal asymptote.